Welcome to Cross-Cutting Concepts activity. This is for stations 2 and 3. So again, the expectation is that you have complete full sentences. You're not having one-word answers. You're not skipping questions. If you were absent, you may need to fill in things that you missed. If you were absent on the day we corrected it, you might just have to turn your lab in. If you were gone one of the other days, you could have filled your answers in while we went over it, and that was the expectation. So at station 2, you had some toy cars there, and you were supposed to place the object in the center of the table. You were supposed to use your hand to gently push the object, and use your hand to push the object a little harder then. But do not let the object fall off the table. So if you are absent and you need to do this lab from scratch, think about it. You have a toy car on a table. You push it just a little bit. What's going to happen to the car? Then if you push it a little bit harder, what's going to happen to the car? What's going to be different? So 5, what happened to the object? What do you think would happen to the object? Well, the object is going to move. So if you actually did the lab in class and you need to clean up your lab and add more to it, you got to ask yourself, okay, what happened? Did you just put the car moved? Or did you add something to it? The car moved, and as soon as I released the car, it started to slow down, and eventually it stopped. Because if you just say the car moved, is it still moving? 1 day, 2 days, 3 days later? So the car started out fast, it slowed down, and it stopped. You could even add, I pushed a car, it was speeding, then it was gradually slowing down, and it stopped about 6 inches from where I pushed it, or a foot from where I pushed it. So what happened to the object? And then, why did the object react the way it did? Was anybody surprised that the car moved? Did anybody push the car and say, whoa, 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 the car moved. What's going on here? So we're used to that. There should be no surprise. We push the car moves. So when we look at the cross-cutting concepts, which cross-cutting concept do you think was modeled at station number 2? Pause the video if you need to look these over. All right, so if you looked at and you put number 2, cause and effect, yeah, you're right. You push the car, that's the cause. What's the effect? It moves. If you push, if there's a ball laying on the ground and you push your foot up against it, in other words, you kick it, the ball's going to move. If you pull on a wagon, the wagon moves. So there's cause and effect, and we're aware of cause and effects. There's all kinds of cause and effects, and we're going to be studying a lot of those cause and effects this year in physics. So let's go on to station 3. Again, make sure you have complete sentences. Don't skip anything. So you're supposed to compare and contrast the 3 objects. Now, if you were in the lab, you would know that there's actually 5 graduated cylinders. One was really little tiny, and I had the very, very large one. So which object has more space inside? How did you answer this? You could have simply said the largest object had more space inside versus the largest or the larger. So complete sentence, complete thought would say the larger object had more space inside. Now notice I use some of the same words in a sentence. That's a great trick to do. When you're having complete sentences, complete thoughts, use some of the same words to answer, in your answer. So what is the use for each object? Well, this is where I could say the use for each object is to measure volume. It's to measure liquids. And technically you're supposed to measure liquids with it, but you could use the displacement method, and we're going to learn that soon. You could use the displacement method, which is really measuring a liquid, so you could actually measure solids in there as well. So number 9, how do the sizes of the object affect what they do or what they are used for? Well, think about that. What's that very little graduated cylinder going to be used for? It's going to be used to measure smaller objects. And the larger graduated cylinder is going to be used to measure, greater amounts of volume or larger objects. So how do the size of the object affect what they do or what they are used for? The larger the object, the larger the volume they can measure. The smaller the object, the smaller volume they can measure. And it would be more precise too, having the larger one the smaller one versus the larger one. And number 10, what are some examples of how size affects how we use something? Well, let's look at some examples. We had hammers in one of the labs. If I had a really small hammer, would I use that for demolition? No, I would probably use a very, very large sledgehammer. which is a really big hammer. Would I use a large sledgehammer to pound in a nail into the wall? No, I would use a smaller hammer. So there's lots of examples of things that we use that have your smaller sizes and your larger sizes. And so the size can impact what you use it for. So let's go down one more slide and let's take a look at the cross-cutting concepts. Which one do you think fits for number 3? If you said number 3, scale, proportion, and quantity are correct. So even though all the objects were the same, they had different uses based on the size of the object. So we're going to stop this video now. So this is for station 2 and 3. Make sure you have complete solid answers before you turn your lab back in or watch one of the other videos and complete your work.